Hi, this tutorial is brought to you by pm-prep35.com. pm-prep35.com is a free PMP training website. Do access pm-prep35.com for mock exams, chapter tests, and lot of process tutorials. In this session I am going to cover plan quality management process. This process is part of quality management knowledge area and it's a planning process. The plan quality management process deals with creation of the quality management plan. The quality management plan details about the other processes within the quality knowledge area, like the quality assurance process and the control quality process. Like any other knowledge area plan process, this details about tailoring guidelines as well as tools and techniques to be used in different processes within this knowledge area. So quality means meeting customer requirements. So this process or the processes in this knowledge area deal with assuring that the customer requirements will be met. So whatever metrics that will be in place, how those will be checked, and what is the plan to meet the customer requirements, and assurance and control quality, which deals with correctness of the deliverables, are all part of this particular knowledge area. So the plan quality management process puts process in place so that defects don't get to the customer's hands, and proper processes are in place, proper metrics are decided, and they will be collected and checked to ensure that the customer requirements will be met. Poor quality is not at all acceptable, but then poor grade is okay in terms of looking at grade as the set of features the product can have. So lesser number of requirements means lower grade, but a lower quality means the customer requirements are not met. So this is the difference between quality and grade, which should be kept in mind while you understand the quality management process. So this also not only deals with coming up with quality management plan, it also deals with coming up with the process improvement plan. The process improvement plan is more concerned about looking at quality as a continuous improvement process, because once you put the quality management plan in place, it doesn't mean that you stick to it, because the whole idea is to have a continuous improvement process. In other words, when you're following an iterative project development method, you want to ensure that any improvements that you identified as part of quality improvement process are factored in, so that better reviews are conducted in the next iteration. So process improvement plan is also part of this particular process, wherein during quality assurance you might come across certain better ways of doing things, so you factor that in or do it in the next iteration. So process improvement plan creation is also part of this particular process. So with that in mind, let's quickly walk through the important points in ITTOs of this process. Since delivering the project requirements is not only concerned with meeting the customer requirements, but also ensuring that all the requirements are met as per customer expectations and that defects do not get into the customer hands, project quality management is identified as a knowledge area in the PIM box. So it's not about meeting the requirements, but how well they are met, or ensuring defects do not get into customer hands. That's why this is a knowledge area in the PIM box. Poor quality means dissatisfied customers, and as a result loss of reputation, loss of further business. So once the stakeholders are identified and the requirements are collected, one of the next processes aimed at is to develop the quality management plan, starting off with outlining the quality principle and quality standards with proper SLAs, facts and figures. So you identified the right stakeholders with the right power and influence, and you get the quality requirements in terms of what is the uptime of the system, and what is the quality control measurements they are expecting. So you collect those as metrics, and then you measure against those metrics. So what is the defect rate that's acceptable, or what is the timeline it's acceptable, what is the percentage of availability time of the system. These are all examples of metrics that you collect beforehand, and while you deliver the product you check against these, so that these metrics have been dealt with properly. So that's how to go there, is what gets covered in your quality management plan. So it can be even with relevance to your deliverables, how you will conduct inspections, how will you ensure defects will be kept under control, or it will be defects would not be getting into customer hands. These are all set up as processes so that you meet what is the expectation of the customer. The plan quality management process deals with determining what quality standards are relevant to the project and ensuring that those standards are being met by the project's process anytime during execution. So this is again about metrics. How will you deal with those metrics? How will you check those they are under control and things like that? The metrics that would be measured and the checklist that would be followed are all determined as part of this process. In case if there are any deviations in the product's quality based on existing metrics collected, then the process is controlled to the standards. So you not only specify the metrics, but you also ensure that they are measured, and then you are ensuring that the actuals meet what was planned or what is the standard. So metrics are anything like defect density or availability time, and you specify that it should be 90%. The availability time is a metric, but the 90% is the plan value, and then your actuals might be something else, for example 89%, which means the customer requirements has not been met or the quality is not good. The tools and techniques for adherence and quality control are decided as part of this process, along with reasoning out why quality needs to be managed and what business impacts poor quality can cause. So you not only specify what are the tools, what are the metrics, how will you handle those metrics, how will you measure those techniques, but also specify why this amount of inspection, or what are the impacts of not putting some quality process in place in terms of addressing the cost of quality. So those are also covered in the quality management plan. The main inputs: project management plan. This is the base plan from which other plans are elaborated. So this is used to start off the quality planning process. Also this has the other baselines like scope, cost and schedule. So based on these you decide the quality of the project or the quality standards, what metrics to use and all that. The stakeholder register is another input, factoring all stakeholder needs and their power and influence to come up with the quality standards. So based on the power and influence of the stakeholders, your system, your product might be used or might be scrapped off. So that's where you need to understand the right stakeholder and their influence and factor them and understand all their requirements. How will they check the acceptance of the product? So those things, if you factor in early, then you can make it part of your quality management plan and keep checking them as you reach milestones. So that's where stakeholder register and talking to them, getting their requirements, really important. Risk register is the next input. What risks will affect the quality or customer requirements, and factoring those into the quality standards. For example, you don't have a quality control department, that might be a big problem in the end. So you identify the risks and try to fill those gaps as part of this process. Then requirement documentation. The requirement documentation has the customer requirements, so it's a vital input. So you have your non-functional and functional requirements there, then your business requirements. So based on this you can decide what could be the metrics. So requirement documentation is an important input to this process. Then comes the organizational process assets and enterprise environmental factors, which are main inputs for all the planning process. In case of organizational process assets, you can look at prior lessons learned, use templates that are successfully used for prior projects. Enterprise environmental factors is about factoring in any external factors that could impact the project or the project quality as such. So tools and techniques. Meetings is a important tool used in this process, wherein you talk with different stakeholders, get their customer requirements, develop metrics and all that. Cost benefit analysis performed to understand the cost of quality, why is certain non-conformance of quality, what impact will it have. So these things are weighed and projected in your quality management plan. The cost of quality is again used. It is one of the tool to assure why you have to invest so much on inspections and things like that. So those are tabulated in your quality management plan. The cost of quality, weigh the cost of conformance and cost of non-conformance, and you can put that in your quality management plan to assure or to say why you need inspections, what would happen if you don't have inspections or reviews. Then there are 7 basic quality tools from which you can choose for your particular project. So these tools are, cause and effect diagram, which is otherwise called as Ishikawa diagram or fishbone diagram. Then you have flow charts wherein you can draw things and see how you can this is used in your inspections or reviews, how you depict your reviews, or how you look at identify the flow of the process, and also checking complexity or cost involved to implement. So there is no need to explain too much about the flow charts, because this is constantly used across many projects and they have a wide usage across the different project management areas. Check sheets usually used to collect data and construct a frequency distribution later. So check sheets are used to collect information when you're on the job or you're collecting data on a day-to-day basis. Pareto diagrams, these are used to find out most common problems. There's a type of histogram, Pareto diagrams, but then their idea is to show the most the cost which is causing the most impact, the probability of something having a bigger impact than the others. So that's what the main cause is used. When you want to find the main cause which is causing the most of the problems, then you use the Pareto diagram, although it's a type of a histogram. Pareto charts a special type of histograms used to describe the central tendency, dispersion and shape of a statistical distribution. The histogram is a bar chart where you have on the x-axis what are the factors that are having what are the factors that should be considered, and then the y-axis shows what is the impact of those factors. So histogram just plots a bar chart. We will take a quick look at each of these in the diagrams when I walk through the different how these look. We can take a look, but just let's walk through all this at this moment. Control charts, they are another tool used to determine if a process is stable. Upper and lower control limits are set and data is plotted to see if there is any consistent deviation from the limits. So there are different rules for the control chart. A process is considered out of control when a data point exceeds a control limit. 7 consecutive plot points are above the mean, or 7 consecutive plot points are below the mean. So these are the things that you take care when you work with control charts. Then you have scatter diagrams. Independent variable is plotted against a dependent variable to analyze correlation. Then you have benchmarking, wherein you base your process on something which has already been successfully used, a process that is successfully used in another project. So you benchmark your metrics and all that based on that particular project. Design of experiments is mostly used in the automobile industry, wherein used to determine what factors might affect the product's quality. Useful in determining the type of test needed and their cost of quality. For example, automotive designers use this technique to determine which combination and suspension of tires will produce the most desirable ride characteristics at a reasonable cost. Then you have statistical sampling, where you take a portion of the sample and check for the quality. So these are mainly used in control quality process. Additional quality planning tools like brainstorming, force field analysis. Force field analysis look at for and against a certain thing which you are trying to weigh the options. So force field analysis, we'll take a look soon how it looks and all that. Then you have nominal group technique to rank different options. Quality management and control tools. So these are the things, these tools, the 7 basic quality tools are used, either one or many of them will be used in your control quality and quality assurance process based on what kind of project you are doing. So that's why all these are shown as tools in case of the quality management process, quality planning process. So output of this process, the quality management plan, this details about how the organization's quality policy or the customer's expectation will be met. Process improvement plan is the next output. All through the project life cycle, it is necessary to revisit the existing process and do continuous improvement. This plan takes care of such frequency and approach. So process improvement plan is concerned about improving the existing process. Its quality is one thing wherein you don't want to just relax once you put a quality management plan, but during your execution you might find a better way of doing things. So you revisit your quality management process through the process improvement plan. So process improvement plan has the frequency about when you will revisit, how will you do it, and things like that. Then the next output is the quality metrics. The quality metrics is nothing but what will be measured by the customer when they are accepting this product, or they are checking the correctness of the deliverables or the end product. So such quality metrics will be identified sitting with the stakeholders, and those will be measured as part of your quality assurance or control quality process. Quality checklist, what parameters will be checked as part of quality assurance process. While your metrics is about what factors will be checked, your checklist will be used during inspection and all that, where you can check whether this has been done and all that, whether 10 points out of the 10 points which has been done, how is one performing, I mean what is expected, what is the actual value. So whether for example some of the points in a checklist can be whether the configuration item is following a proper naming convention. So there may be naming convention already specified, and then you check that when against the deliverables, and you write down yes or tick mark the yes for the particular deliverable. So these are part of your quality checklist. So project document updates happen. Basically when you're dealing with quality, you might have to revisit your requirement documentation or or other documents like the risk register and make updates to it. So with that let's quickly walk through some of the templates that I got from the internet for the quality management plan. So the quality management plan has a purpose, scope. This plan, so it has details about standards, policies, reviews, checkpoints, and other quality improvement methods to be implemented on the sample project, on the project. So this is identified in the purpose and scope section of the quality management plan. Then you also specify quality roles and responsibilities, who will take care of what, quality assurance responsibility, who will take what role, when will the sponsors be involved, team members will be involved, will be specified as part of the quality roles and responsibility. The main aspect of the quality assurance or the quality management process is quality checkpoints, deliverable reviews. So different phases, what will be the checkpoints, what reviews will be conducted, how will the product readiness will be checked. All this will be part of your quality management plan. So that's what you can see under quality checkpoints, deliverable reviews. Then requirements review, how the requirements will be reviewed with different stakeholders. That's also one section here. So you're talking about a lot of review checkpoints, so that you ensure that the customer's quality will be met. So you are doing that across phases, and how you will do that is what is specified in your quality management plan. Security review, so you are not only concerned about the functional requirements, you are also concerned about the non-functional requirements, which relates to security, availability, and all that. So those things are also having reviews. How will you do that? That's what is part of your quality management plan. Code walkthroughs, when will you do it, what frequency, what kind of things you will check, that is also part of your, is a section in your quality management plan. Project management documentation reviews, you not only are concerned about the deliverables but also process deliverables. You have your documentation done, those will also be reviewed by the internal quality control department or the manager within, or it will have one more round of review in a panel, in the client panel. So we are talking about intermediate deliverables also being walked through and reviewed, so that you don't wait until the end product is delivered. Some defects can be caught in terms of design review or the requirement walkthrough. Testing, what kind of process will you follow, how will you ensure the product will meet the customer needs. So that also is one of the sections in your quality management plan here. Production readiness checkpoint or business value testing are all specified. How will it be conducted, who will conduct, what process will they follow, and all that is part of your quality management plan here. Standards, practices and guidelines, metrics, what metrics will you check, so that is also listed down in your quality management plan. So that was one format of your quality management plan. I just pick up one more. This also covers, if you look at the table of contents, you can find out it has a section for quality assurance, quality control, quality management approach, planning and overview quality. It has quality objectives, measure project quality, control quality also will have a section in the quality management plan. So you can easily find out how will you measure project quality, what metrics will you follow. This is not very different from what we discussed and we saw in the previous quality management plan. What methods and tools will you follow, what roles and responsibilities, tools, environments, quality assurance, how will you do it, how will you assess, how will you review, how will you audit. So all this, how will you improve quality. Sometimes you want to pull out this as a separate document as a process improvement plan, but then it depends on how you want to handle it. So corrective actions, what corrective actions will you take, quality schedule, any appendix. So these things are part of this quality management plan, not very different from what we saw in the earlier case. So another quality management plan here, it deals again with the different processes: project quality management overview, quality planning, quality assurance, quality control, all have sections here. What metrics will be checked, how will you analyze data, what are the roles and responsibilities, then revision history and all that. So that's about the different templates. So they all deal with the different processes in the quality management knowledge area, what metrics will be collected. So apart from that, you will also provide details about the cost quality, cost of conformance, cost of non-conformance. So let's quickly walk through 7 basic quality tools that we talked about in the tools and techniques section of this particular process. Here is the cause and effect diagram. The cause and effect diagram has the cause as the the effect and the head, and then you see what are the causes that can lead to it. Here the car will not start. This is one of the effect. What could be the causes? How they are how you are measuring gas gauge is broken, so that's one of the effect. Then you can see starter broken. So these are some of the reasons why cause will not be the car will not start. You can see lost the keys out of gas. So you brainstorm and come up with what are the different causes that a car cannot start, and you put that in a fishbone diagram, and then you find out what could be the problem. So this is a rough way of looking at a problem when you start off. So that's where the cause and effect diagram is really useful. Based on this, you will take some of them and then you probably plot it in a histogram. Next comes your Pareto diagram. Again, the Pareto diagram is a type of a histogram. So before that, let's look at how a histogram looks. The histogram is again a bar chart. These are, so you can see how it looks. You have in the x-axis height in inches, and then frequency, the number of people in that height. So you can see that the first few bars are small, then comes the bigger bars. But when you go to the Pareto chart, you will identify the most problematic ones in the first few bars. So the first cause will be the most problematic one. So here you can see parking is difficult. This are all customer complaints plotted against how many of them. So customer complaints or different customer complaints or parking difficult, sales representative was rude. So this is plotting some of the issues in a probably in a clothing store. So there it's plotting, it has got these details from the survey from the customer, and the customer most problematic one is parking is difficult in this particular clothing store. So that is the most problematic one that is causing the customer complaint. So you are also having other things, but you can easily make out which is the problematic one. So if they solve this one of difficult parking, then the customer will be a lot more satisfied. So that is the whole idea of the Pareto diagram. The Pareto diagram, again, it plots the most problematic issue as the first one, so that if you eliminate that, then probably the other ones are not so significant. Then check sheet. You can see the check sheet are mostly used in with doctors and all that. So here you can see one wherein you have taken some of the test and how probably you will have a timeline when you will go and check and you will mark whether things are fine. So that's where the check sheet is used. So we are talking about quality management for different contexts. So that's where we are having different types of charts and check sheets coming into picture. The control chart, you have an upper control limit, you have a lower control limit, and you can see when you plot it, too many plots on one side of the mean means that your process is not doing fine. So 7 plots on one side means the process is not doing fine. So you have an upper control limit, the lower control limit. So these things are used to check the performance of your process. Then the other one is scatter diagram. You can easily make out, you're drawing a weight against height and see how it is scattered. Based on this, you can see what is the most common combination of weight and height combination, and then you can do further analysis. And so design of experiments is mostly used in the automotive industry. You are having a combination of impeller, motor speed and control, and then you are deciding the valve here. So this will help you decide what kind of valve will be used based on the motor speed and the impeller that's used in for an automotive or an. Then comes the force field analysis. This is another quality planning technique, but it's not part of the 7 quality control tools. But here you can see the driving force and the restraining force for something like being thin. So that's where, what are the driving force, what are the restraining force, why people choose to be thin, or what are the issues with being thin and things like that. So you can easily make out what are the causes of being thin. So driving force, restraining force. So the force field analysis looks at things this way. So wherein you are also brainstorming driving force as well as the restraining force. Then there is a nominal group technique, which is more concerned about putting some weightage. I mean, for each participant, you are looking at the issues, asking them to rank it, and then you get the priority, the total points you calculate, and from that you can make out which needs to be handled in high priority. So there's the list of metrics. Metrics are mostly they are data related. So here you can see percentage of employees leaving because they are satisfied, they are not satisfied, percentage of employees proud of work they do. So these are some of the metrics. So you can see availability time, what percentage, 99% it should be available. So it will be mostly related to percentage, or you can easily make out with numbers. So that's where the metrics decide about, they are mostly number oriented. Cost of quality. Cost of quality is cost of conformance and cost of non-conformance. Your prevention costs fall under cost of conformance. Appraisal costs fall under cost of conformance. Internal failure rate costs fall under non-conformance. External failure costs fall under non-conformance. So rework, scrap are all part of internal failure costs, and external failure costs you have liabilities, warranty work, lost business. So these are some of the things that you need to keep in mind while you come up with the tools and techniques. You need to understand what each of these tools mean, how they look, and so that is about plan quality management process. Do visit pm-prep35.com to access a lot of mock exams, chapter and tests. Thank you.